Dear all, good afternoon. I will start the webinar of Safe Mooring Operations, OCIMF Guideline, Rightship Requirements, administered by City Unity College. I'm Evangelos Ioulas, Marine Trainer and Navigation Assessor of City Unity College, and at this webinar we'll analyze risk involved in mooring operation, safety factor groups, hazards of snapback, or as we call it, recoil, and brief guidelines how to moor safely. Furthermore, I will give the most important recommendation by Oil Companies International Maritime Forum, OCIMF, and of course an analysis of Rightship Inspection Questionnaire, the last version 3.1, especially Section 10 of Mooring Operation. Before I start, I have to explain, I have done also the same in my previous webinar, what we do as City Unity College Maritime Department. Maritime Department has the responsibility to run two different academies. First academy, the program of Bachelor of Science in Maritime Transport, Technology, Shipping and Port Operation, plus COC Second Officer. Also the program of Bachelor of Science in Marine Engineering, plus COC Third Engineer. On behalf of Arab Academy of Science, Technology and Maritime Transport, based in Alexandria, Egypt, since October 2017. Also, the second academy is the program on behalf of Mediterranean Maritime Research and Training Center, Society Cooperative of Malta, since October 2022, and there is the program of Officer in Charge of a Navigational Watch, plus Yacht Academy. For your information, this webinar will be approximately 60 minutes, plus the questions of the participants. I have finished with my prologue and now we have to go to our presentation. First of all, let's give you one introduction about mooring operations. Mooring operations are considered one of the most dangerous tasks on board ships, along with entry to enclosed spaces, the most dangerous task. The dangers are very real regardless of experience. Even you have smallest of lapses, even those far from the mooring deck, this can have significant consequences during mooring operation. Even though shipping industry is innovative industry and there are various innovations like the automated mooring technology in order to reduce the hazards associated with traditional mooring system, still the majority of vessels rely on mooring arrangement, mooring equipment, ropes and winches, and of course human factor, which can be the strong link or the weak link if human factor is not well trained. Let's see of the generic point of view risks involved in mooring operation. First of all, poor overview by the team, and especially by the leader of the vessel, the master, in relation with mooring lines, mooring arrangement, and crew. Stopper breaks, so this is equipment failure. Oil link from which slip injury, so we have an unsafe condition which create an unsafe act, so we drive to an accident. Too cold because of adverse weather condition. Crossing line, this can create friction between lines and increase snapback zones. We'll see later on how this can be. And of course, it's an unsafe practice. Sea rising, also in relation with weather. Lines in a mess on a mooring boat, especially when we use a mooring boat in order to give long line ashore. Wire ropes tight and slack of different material, elasticity and breaking strength. This is in relation with ropes specification. Line thrown without teledocker, so how we can give line ashore without be a man there. Strong current, moving to and from in relation with shiftings. Standing in a bight or coil, this can create to us to fall down. Too many turns on a drum, sitting on a line, attending lines, and wrong outfit. Also, mess on a key when we're going to moor our ship, line caught in fender, and this can create a snapback situation, bad communication between all parties, like pilot, master, mooring boat, tag master, and the crew fore and aft, Lines lying too long in sun and water, so we don't have proper housekeeping of the lines. Language confusion, especially due to the fact that we have multi-ethnic crew on board, and this can create language confusion because we don't speak all crew the same mother tongue. Bad lighting, poor communication between pilot, captain and tug. This is in relation with, generally speaking, with bad communication. Line sinking before it parts. Parts means cut it to two pitches. Wet paint, unaware of risk, being in a snapback zone. This is in relation with onshore and onboard training of the crew. Standing in a line, draught changes, line comes off bollard, or they have a dangerous steep ankle. We'll see how a steep ankle can create tension of the line. Line around propeller, several lines on the same bollard as unsafe practice. Mooring incidents, when analyzed, can be categorized into 4 safety factor groups. This is in relation with risk management. Individual actions, this is in relation with human action by operational crew. Local seaboard condition, predominantly in relation with ship motion, or there is a swell on the port and things like that. Organizational influences, organizational shortfalls, for example, lack of safety culture, safety management system that they are not effective on board, lack of supervision by company, or lack of training by company or onshore support. Last but not least, design and equipment, design shortfalls or component failure, for example, mooring line parted. Here we have some pie charts in relation with incidents. As you see, hit by parted ropes 53%, hit by non-parted ropes 42%, and only actual equipment failure only 5%. Next pie chart is the reason that we make this webinar, just to show exactly the consequences of a human that get involved with an accident during mooring operation. As you see in the percentage, more than 60%, we have very serious injuries, plus 14% fatality. Let's see of the generic point of view analysis of these factors. First of all, the mooring area is dirty and all surfaces are in need of maintenance, so proper housekeeping is very important. All surfaces are painted the same color, hiding trip hazards. There are trip hazards that must be painted with different color, that's why we use yellow color for that. There are no hazard lighting or warning marking. Also, generally factors can be found in equipment, in the work processes through the safety management system of the company, crew qualifications, crew concentration, and this is in relation with stress or fatigue of the crew, ship safety culture, and last, weather. Also, crew not aware of snapback areas, they don't know exactly what is snapback area, or crew standing within a bight or coil, or crew has complacency. Okay, insufficient training, the person supervising also involved with the operation, and here I have to give one example. We have a duty officer on deck, aft, let's say, and is with 3 ABs, and instead of checking the position of his colleagues, he tried to do the job of AB. So he is not or she is not watching. The job of supervisor is to make a risk assessment all the time, and of course to pass the orders or intervene if possible. No proper handling of towing lines, communication, monitoring issues. What we believe as humans, we believe that things are safe if nothing happens. So because of that, we decrease the level of safety. And of course, if we decrease the level of safety, maybe we lose our concentration, maybe we slacken our procedure. So when suddenly something happens, not because by one factor, but because of a number of interacting factors, as we're going to see in the forthcoming slides. Preventing accident is about reducing the risk of these factors. Here we have the most common risk, categorized risk according to risk management. First of all, in relation with equipment. use of all damaged wire or ropes. Wire for tanker ships, ropes more or less for dry cargo ships. Poor equipment, poor design mooring system, no overview of mooring area, hazard tripping rig site not highlighted. Also work process like lack of communication, poor line handling. But as you see, the most risks are in relation with human factor. So crew qualification, maybe not lack of knowledge of mooring operation, maybe they don't know mooring systems as well. Unclear instruction by the supervisor or by the team in general. Lack of information, lack of supervision by adequate personnel, adequate officer, competent officer. Small untrained crew, ineffective on-board mooring training without identifying and understanding the danger associated with snapback zone. Very important is the crew concentration in case that the crew concentration will be decreased if we have stress and fatigue of the crew. Furthermore, ship safety culture, like procedures not followed by ship, shortcuts taken, we don't follow the steps, okay, we jump the steps, standing in a wrong place or in a bight, quick mooring sometimes versus safe mooring, no risk assessment process prior to mooring operation, cluttered mooring area or deck. This also can be related to weather conditions like ice, slippery deck, wind force and current. In relation with risk management is the science that can identify the risk, analyze the risk, and can also make us to make a decision if the risk is tolerable or not. If the risk is tolerable, we can proceed with the action, with the job. If the risk is not tolerable, we must mitigate it. So, the effectiveness of the mooring line is influenced by two angles. The vertical angle between line direction and the pier deck, and the horizontal angle between line direction and parallel side of the vessel, and this is in relation with breast and spring lines. We'll see later on how this works in OCIMF guidelines. Here we have a risk management formula, risk analysis formula, which is called bow tie approach. Normally shipping companies, they use bow tie approach as risk analysis or matrices. What we have here is hazardous activities, personal injury is the incident. So, on the left side, we have the threat. Threat can be mooring operation. Between threat and incident, we have controls. So, what kind of controls? Preventative controls in order to avoid to reach to an incident. On the starboard side, on the right side, we have consequences of the injury. For example, in our case, maybe hospitalization, maybe serious injury, or even death. So, in order to mitigate the consequences, we have, as we call it, reactive controls or mitigating controls. This whole story is called bow tie approach. Let's analyze a little bit in our case. So, our example here is mooring operation. Okay, the preventative controls can be the following: vessel mooring equipment of appropriate standard for operation be undertaken. Mooring basin design factor, this is in relation with shipbuilding, let's say. Housekeeping standard maintained in all areas. Housekeeping is very important component for level of safety. Trade competence of personnel to perform required duties. Continuous on-board training by crew, by officers. Sufficient personnel for required operation. Effective supervision by officers during operation. Communication between all parties. Pre-mooring planning held between bridge staff and mooring officer, or as we call it in communication, toolbox talks and work planning meetings. With that kind of preventative controls, we just erase the problem of an incident. We will not have an incident. Of course, we can add more in this case. The mitigating controls are, in case that we have already the incident, damage mitigation procedure. Of course, the crew must be familiar or must know how to stop procedure, how to run in an emergency situation, how the crew and the officers can make emergency reporting, and of course record keeping as evidence retention, capability of crew to deal with incidents because there will be incident investigation by someone, use of third-party assistance, and of course lesson learned from that kind of incidents. Snapback, also called recoil, is the tendency of a broken edge of a tension line to draw back rapidly after a line break. So, what we have here, statistically, the majority of serious incidents and accidents in mooring areas involve parting lines, lines that cut into two pieces. The sudden release of an energy stored in the tension mooring line when it parts break is defined as snapback. Of course, snapback, most of the rope manufacturers, they have already make a result. How is the recoil velocity? The recoil velocity of a snapback line is up to 800 kilometers per hour or 500 miles per hour, can be considered like a rifle shot. That's why it's very dangerous in case that a line is parted. Always pay attention, help to improve consistent understanding by using mooring area drawings, changing snapback zones due to changing configuration, minimize the amount of exposure to line under tension. Even lines with low recoil characteristics can have snapback risk. For example, in case of crude oil tankers, they don't use synthetic fiber lines, but they use wires. And of course, these wires, they have a mooring tail by nylon. Even this mooring tail by nylon can have a snapback risk. Use ships planned during onboarding training and toolbox talks to illustrate snapback zones. And of course, very important matter is to observe the position of colleagues and intervene if appropriate. Nowadays, we don't paint the deck in order to identify the snapback areas due to the fact that the mooring area is considered as well a working area. Now we just put a stencil or a place or a stencil or a plate says that danger entering a snapback hazard zone. The entire mooring area has snapback risk. This is something to thumb. Also, 10 rule of thumb, assessing the mooring. If weather change became worse, put extra moorings. Mooring lines should be symmetrically, and we'll see later on in OCIMF guidelines. Breast line are not effective when they are perpendicular to the ship center line, because breast line are vertical line and they must call in a vertical angle with the hull. Spring line are more effective when they run fore and aft. This is the reason of spring line that exists. Line in the same service should be of the same length. The smaller the vertical angle, the greater the resistance. Also, this is in relation with breast line predominantly. Okay. Line in the same service should be of the same diameter. Mooring line, vertical angles due to height difference should be kept to a minimum. All mooring line should have the same material size and composition, because if they have different material, the weakest rope will break first. Mooring lines should be reeled in a direction and has brake holding capacity. Brake holding capacity considered greater than the heaving power. Also, in order to moor safely, always wear protective safety. Keep clear any bite in a line or coil. Stand when clear of a taut line under load. Try to keep control of a line. Try to make sure the line is properly secure. Try to anticipate any situation which may cause a line to run out of control. Keep clear of snapback zones. Never, and this is for every ship, stand too close to a winch drum or bit when holding a line. Apply too many turns to a line. Bend the line. Stand in a bite of a line because you fell down and actually you have an accident. Try to catch a running line by grabbing it or with your hands without wearing protective gloves, or even you wear protective gloves. This is also dangerous, or by stepping on it with your foot. Now we have to give you some information about recommendation by Oil Companies International Maritime Forum. Even though OCIMF are predominantly for tanker market, nowadays because of Rightship inspection questionnaire, because we have to discuss also about Rightship inspection questionnaire. They have already put elements of OCIMF MEG 4, Marine Equipment Guide 4, inside Rightship inspection questionnaire. So actually you can see all that kind of information for every kind of vessel. First of all, in this figure, all these figures are from OCIMF book. The horizontal angle of head, stern and breast line must be less than 15 degrees. Here, as you see in this figure, we have spring lines, breast line, head line and stern line. Originally, primary lines are considered breast line and spring line, and secondary lines are considered head line and stern line. So, in a case that we have mixed mooring system, for example, we use ropes and wires. In this case, we'll put wire because they have better strength as primary line, and fiber ropes, synthetic fiber ropes as secondary line, head or stern. Also, the vertical angle with the horizontal plane must be less than 25 degrees. The effective force is proportional to the cosine of the angle. So if the angle is 25 degrees, the line is effective for 91%. If the angle is 45 degrees, the efficiency is reduced to 71%. Also, breast lines, as we say, breast lines are vertical line with the hull and try to keep our vessel stand still in the dock. Breast line are most effective on the longitudinal axis when they have angle 90 degrees with the hull. As you see here, the tension is less than in case that we have an angle 45 degrees with the hull. So the tension will be increased. Also, spring offer the greatest holding power in longitudinal direction. As you see here, they are in a parallel direction with the hull. And of course here the tension is less than in a case that we have increase of angle and try to call with 45 degrees angle or more. As you see, the tension will be greater. Also, the impact of head and stern line on the total holding power of the mooring configuration is less important than the influence of spring and breast. This mainly because lines are too long. Okay, this is one reason. Very short line must be avoided. They always take the most important part of the load. As you see here, short line can increase the tension. Here we have a short line 88-ton tension. In case, instead of the other side, that we have actually long line and the tension is only 52 tons. All the mooring ropes in the same group working in the same direction must have the same tension if possible. Also, there must be a balance between the four groups, head and stern line, spring and breast. And of course the proposed configuration, if we have a wind, let's say southeast or east southeast, 4 breast line aft plus 1 stern line, 3 head line plus 3 breast line forward. Also, the number of line is function of the size of the ship and the prevailing weather conditions. Of course, as I told you before, if we have adverse weather conditions, we put extra moorings. But anyway, number of line, it depends about the size of the vessel. Normally, a big size vessel, let's say a Cape-size bulk carrier or a Panamax bulk carrier, they use the system of 4 to 2 forward, 4 to 2 aft, normally 12 line at least in order to moor the vessel properly. Now we have to discuss about Rightship. Nowadays, Rightship, if we start to give a definition, what is Rightship and actually what is the role through the vessels. Here, of course, I have put one definition from their site that as they call is the world leading environmental social governance, EGC, focused digital maritime platform providing expertise in global safety, sustainability and social responsibility practices. Okay, maybe this is not well understand what is that. What actually they do? What they do is vetting inspection, second party audit on behalf of charterers. That's why Rightship right now, especially in dry cargo vessels, they are like a monopoly. Rightship was created in Australia and nowadays have offices around the globe. Let's see that Rightship, they have developed since the last 4 years, let's say, a questionnaire. This questionnaire now we have the version 3.1. 3.1 version start to be effective since September 2024. Rightship Inspection Questionnaire 3.1 comprises of 16 sections. Every section can identify different part of the vessel. For example, section 3 is in relation with navigation. So there is a question about navigation, about competency of officer during navigation system with navigational aids, radar, ARPA, ECDIS, and so on. We have section 4 about safety management system. We have section, let's say section 7 about fuel management. Section 8 about cargo handling. Section 10 is in relation with our case now about mooring operation because this is our subject, and can reach until section 16, which is ice navigation. So in relation with section 10, they have incorporated in their system Marine Equipment Guide 4, which is according Oil Company International Maritime Forum, so they use principle by tanker market. For example, not all, but some principles may be considered for other type of ships, as they say, like section 5 mooring lines, section 6 mooring wheels, and appendices, and they just give guidelines. Section 10 has 23 questions, and these 23 questions also Rightship gives some guidelines in order vessel to be prepared properly, as well as company to be prepared properly, and of course that can be aid to memory for the Rightship inspector. First of all, in relation with mooring operation, generally speaking about section 10, company must establish guideline and procedure for the inspection, maintenance and wear zone management. Company safe mooring campaign, so they have to make let's say training of the crew, onshore training through a training center or in-house training or on-board training. Procedure and record of winch brake rendering test. We'll see that winch brake, they must have a test. We'll see what Rightship inspection questionnaire says about that. Regular visual inspection of all type of fair leads should be incorporated also in the plant maintenance system in case that these fair leads needs maintenance. For example, they are heavy corroded or they are broke, let's say. Plant maintenance system for mooring ropes and equipment, emergency towing booklet. We'll see what is going on now with towing booklet, and inspection and PMS anchoring equipment. This is of the generic point of view, the section 10 elements. Let's see now one by one the questions. Okay, of course I'll try to be brief for this question because I need more than 2 or 3 hours in order to explain by detail. So I'll try to be brief to you. First question, they just ask that has the company established guideline and procedure for the inspection, maintenance and wear zone management of the mooring lines, and of course if they have been implemented. So what the inspection have to do, have to make a contact random check of the ship mooring line management plan. So there must be on board a line management plan according Intertango guidelines of line management plan. So they use again principle by the tankers. Okay. And of course here they give a definition what is line management plan. Is used to manage the operation and retirement of mooring lines and tail, if any tail for dry cargo ships, because as I told you, Rightship inspection questionnaire is predominantly for dry cargo ship, not for tankers. Also, they have to check that all types of mooring line experience localized fatigue and damage caused by common line routine and deployment process. So they have to check, and they have everything to be written in a line management plan. Also, about conventional fiber lines that normally a dry cargo vessel has, can be at routine interval and of course must be inspected by a competent person. Who is the competent person? Normally on board, competent person is seaboard safety officer or the master. So they just give an asterisk about that. The personnel responsible for rope inspection must be properly trained to recognize rope damage and to understand the rope inspection procedure and retirement criteria. So he must be well-trained person in order to make that kind of routine checking. Question 2. Does the vessel manager carry out regular safe mooring campaign? So this question is in relation with company, with vessel management. And of course, here they have to give to the crew case studies and lessons learned from these case studies from accidents, incidents, or near miss. Near miss is an accident waiting to happen. So, according the suggestions by Rightship, there are different ways of recording and ranking the lesson learned from incidents, and they have categorized into 3 levels: immediate incident notification, lesson learned from an incident investigation, lesson learned from a review of incident trends. Question 3 is in relation with certificate of mooring line or mooring tail if applicable, available on board. So they have to show, master have to keep certificate of the rope in order to be shown to a Rightship inspector. Question 4, do mooring line and mooring tail comply with industry guideline? So they have also to check that the line design brake force of the lines are not above the specified limit according to manufacturer details. Question 5, is there procedure for testing which brake rendering set? Of course, what we have learned through safe practice is that we set the brake 60% of minimum braking load of the winch. So this is something that we have to know. Of course, this must be also written through a line management plan or also written through safety management system. Let's go in brief. Question 6. Are the mooring line correctly deploying a tendent? So, one example they give here by Rightship inspection questionnaire guideline, that if a vessel runs 4 headline, all 4 lines must be constructed by the same material rope type. So we must have same spec, same specification of the rope material. And of course here they just continue. Lines should be led so far as possible without sharp edges of direction. Wires and synthetic fiber ropes need to be kept separate and not allowed to cross or let through the same lead. And of course, what we have already said to OCIMF guideline are as follows, like breast line must be run so far as practicable from as far forward and aft and at right angles to fore and aft line of the vessel, and so on, what we have already showed you before. Question 7. Are there sufficient crew members on board to assist the mooring operation? And this is also in relation with human resource management on board and human resource management on board through the crew management of the office. So we must have sufficient crew, and this crew must be well trained and familiar with bites, snapback zones, connecting the tag line, let go tag line, and all that kind of stuff. Question 8. Are all mooring line or winches correctly reeled on drums? So the effectiveness of the brake is dependent upon the rope being correctly reeled into the drum. So it's something that must be checked by a Rightship inspector. Question 9. On slip drum winches, have the split drum been set up correctly after the completion of mooring operation? Also, slip drum winches are designed so that the line under tension is on the first wap of the drum, providing maximum holding power in order to be efficient through mooring operation. Here they have discussed maybe question 10 is not applicable for dry cargo vessels because they don't use mooring wires, but in case that there is one cargo ship, a dry cargo ship, that they use mooring wires, they use mooring tail. This mooring tail, of course, must be according to industry guidelines, as you see here, connected with shackles, mandal or Tosberg. Also, 11 question, are the mooring ropes stowed clear of the deck and are mooring stations when lit, clear and free from oil leaks? Of course, here is in relation with housekeeping that can upgrade the level of safety. So the mooring station must be well lit, no any broken illumination or poor illumination, clear and free from oil leaks, and the deck suitably prepared to prevent slips or trips of the crew. The mooring ropes must be stowed clear of the deck, actually in a pallet. The area must be free of obstruction, which could hinder the view of the mooring deck. The mooring station, so far as possible, must be painted with a non-slip treatment. Mooring areas contain many trip hazards and all surfaces must be painted the same color, hiding trip hazards like save all, windlass, platform and so on. Also, that kind of information exists through Safe Mooring Practice booklet. Here is in relation with heaving line and especially the edge of the heaving line, which is monkey fist. So the monkey fist normally cannot be made by iron, because if made by iron, can hit, let's say, the boatman on the quay or any gunman on the quay. So here there are suggestions by Rightship that the monkey fist should be made with rope only and must not contain added weight in material, so any iron inside. Safe alternatives include a small high visibility soft pouch filled with fast draining pee or similar with a weight of no more than 0.5 kilos. Also, we have already discussed about that at the whole mooring deck area marked with clearly visible signals as considered as danger. Here we have one area, let's say this is a spring area of a ship, and this can be plate or any kind of stencil that you are entering into a snapback zone, because nowadays all mooring area is considered dangerous, all mooring area is considered snapback zone in order crew to be aware of that. Also, if they are appropriate stopper in use and there are mooring ropes turned up to beach correctly, so in this case that we use stoppers, this is also let's say seamanship practice for some who don't know that. So with fiber ropes the stopper use must be of the same material. One exception is in relation with polyamide rope, nylon rope, that the stopper must be from different material than nylon, because there is no any kind of friction nylon to nylon. Okay. 15. If there are any control of leakages, operating level, brake drums, brake linings and pins of the winches, as well as working access arrangement to the winches. So all the winches must be, as they say here, fully accessible. Okay. Also, they give also some, let's say, guideline. The brake drum must be free of corrosion, pitting and rust scale. The grease nipple must be free of rust, paint, salt and grit. Check the brake lining for significant wear. Brakes must be examined to ensure all leakages are working correctly. Equipment maker manual provide detail for the permitted minimum brake band thickness and so on. So this is in relation with brakes and generally about brake drums. Also, pedestal fairleads, roller fairleads and other rollers that actually help us to give line ashore must be well greased, free of any grooving corrosion and free of turn. So also this can be checked by the surveyor. As well as same for 17 question about bits, chocks and other items. So apart from being in excellent condition, especially for that items, must have also a safe working load of it, shipboard fitting must be marked. Okay. Question 18 about windlass, anchor, locking bars and cable. This is in relation with anchor awareness. So here there must be inspection of anchor shankle, swivel, the joining shankle like enter shankles, the D-shankle which is the weak link of the anchor, crown pin and so on. This must be checked that they don't have any, are not wear down or they have any missing item. Inspection of cable for damage and missing studs. Of course, this is also must be checked the Ajax class society's anchor cable replacement, if any. Inspection of cable markings, both permanent and painted. And some other equipment that are predominantly within anchoring system. Okay, this is question 18. Question 19, have the anchor be tightly secured in a hose pipe. Something that is common, that with this moor alongside, the anchor are not in use, so they must be secured by brake and guillotine, and the guillotine, of course, the anchor should be housed in hose pipe properly. Guillotine is to secure the anchor and of course the chain. Question 20. Are the chain locker door firmly buttoned down and are bitter end securing arrangement? So this is in relation with bitter end of anchor system. Okay. Must be also marked and well painted and so on. Question 21. If the master aware of the limitation of anchoring equipment, of course here master have to check the anchoring equipment and to read manufacturer's recommendation or any other recommendation by inspections. Question 22. Has the vessel been provided with ship-specific emergency towing booklet? So for every vessel since 1st of January 2012, the emergency towing booklet should be ship-specific first of all. Booklet, plan and poster, minimum 3 copies should be kept on board and locate in the bridge, the forecastle space, the ship's office or cargo control room, and of course the emergency towing procedure shall include drawing of fore and aft deck showing possible emergency towing arrangement, an inventory of equipment on board that can be used for emergency towing, so what kind of instruments we have as equipment in order to make emergency towing of our ship, means and method of communication between all parties, between the tag in front of us, let's say, that help us, salvage tag, sample procedure to facilitate preparation and conduct of emergency towing operation according to SOLA 74. The last question is, let's say, more or less a typical Australian question due to the fact that Rightship is actually an Australian company. So they have incorporated a local regulation into Rightship inspection questionnaire, and this is in relation with ports of Pilbara and Rio Tinto. These ports are not exist in Brazil but in Australia. So also maybe for your ship this is not applicable, maybe your vessel don't go to Australia, and of course this is for vessel of dead weight more than 120,000, so cape size or more. So here the requirement for cape size with dead weight more than 120,000 calling the port of Headland in Australia have to set of 120 ton safe working load, bits and leads, and this come into force 1st of February 2021. Pilbara Ports Authority requires all vessels with dead weight 120,000 or more to have at least one set of bit a Panama lead roller fair leads on the aft deck or near the center line. The Pilbara Ports Authority towing arrangement, associate foundation, and supporting structure must be subject to periodic survey at least once every 5 years. Pilbara Port Authority towing arrangement must be permanently marked with their safe working load and appropriate serial number so that certificates can be easily cross-referenced. Okay, and the last, ships must also hold a class certificate attesting to strength of Pilbara Port Authority towing arrangement, foundation, and so on. Okay, I have finished with the questions of Rightship inspection questionnaire. Of course, my time is limited to explain it more, but I have to show you observations from previous vessel, from previous Rightship inspections. Okay, here I use the word observation. Of course, the most common word for that is not observation, it's let's say non-conformity. Why? Because we need an immediate action by the vessel, corrective action, or by the company. Here, let's give you a brief some observation in order to be more familiar with you, to understand me more. Let's say no management plan provided with procedure for inspection. So the vessel does not have no line management plan. Okay. Another observation, one of the poop deck ropes, reel on drum, was observed by ice splice in poor condition. So 4 new ropes have been ordered. This is a corrective action, let's say. Also, mooring which break rendering point is calculated offset of 80% of a minimum breaking load according safe practice and according guideline by OCIMF as well as Rightship must be 60% of the minimum breaking load. The aft mooring area is not sufficiently illuminated, as we say, must be properly lit. So that can be observation or non-conformities by an inspector. Also, one observation, the mooring line forward and aft mooring station used on the same lead were of different type, size and material. So we have different lines from different material. For example, we use line from nylon or use from polypropylene, and actually polypropylene has less elasticity than nylon, so can break first. Okay, the aft mooring area is not also sufficiently illuminated. Also, painting of snapback zone on forecastle and poop deck notice giving false sense of security instead of considering the whole mooring area as a danger zone. As we say, all mooring area is considered a danger zone. There was not warning of snapback areas around either of the mid-deck mooring winches, so same as the previous observation. Also, here they have mooring, forward mooring area, one guide roller center aft was found wasted with sharp edge at lower end. Forward mooring station, port and starboard windlass motors observed with oil leaks. As we say before, that we have to prevent oil leaks from mooring station or any wastage from, let's say, guide rollers, for example. Okay, I think I finished. Here are my sources about OCIMF Safe Mooring Practice Rightship Inspection Questionnaire. Of course, if you like more information, here is my CV. If you like to contact me, I just have my email. I would like to thank you for that. And I have some questions, if any. I have to see some questions. As far as I see, we don't have any questions so far, so I have to close the presentation. Again, I have to thank City Unity College Maritime Department and IT Department for that. Thank you very much.